Okay, what's up, guys? It is chapter 2 of psychological research. Today we're going to be doing biopsychology. Okay, we all love biopsychology. So, how does a television content impact a child's behavior? So, why is this research important? At one time in history, people believed that the earth was flat and mental illness were caused by possessions. People can be very wrong in their ideas about the world. When they do not rely on evidence to support their claims, research is mandatory. A process in validating claims is called scientific research. It is empirical, is grounded in an objective, tangible evidence that can be observed time and time again, regardless of who is observing. Without research, you would only have intuition and groundless assumptions. Through research, we are able to prove certain ideas through study and testing. Psychology is a science, therefore, research is requiring to not only further investigate on some things, but to provide verification and support the findings. So, Figure 2.2, some of our ancestors in the world and over the centuries believed that trephination, trephination is just the practice of making a hole in the skull. Shown here, it allowed evil spirits to leave the body. This cured mental illness and other disorders. So trephination obviously was unethical, and a lot of people did end up dying from this. Putting holes in skulls is not the most ethical thing to do, and I just really don't think there's a spirit possessing that person. Maybe it was just a disorder. But basically the scientific method is just heavy proof that something that we need to judge something objectively. So the scientific method, or scientific research, is pretty much just a really thorough thought, objective observation of something. So we can understand if something is objectively right by looking at statistics and looking at and doing methods to find out if something's right or if something's wrong. Which in math, actually, there's things like laws, there's theorems and conjectures, and they can all mean different things. You know, some like a conjecture is something that's not really proved. A law can be something that can be rectified, and a theorem is pretty much a conjecture evolved, which is something that has been research done and proved. So, research has taken us far away, as you can see, from where we originally started. So the use of research information, advertising campaigns often claim to be based on scientific evidence, when in reality is based on belief. Okay, maybe this is not the biopsychology lecture. Okay, I lied. This is not the biopsychology lecture. Okay, it's fine though. We're still gonna love this. So thinking critically about claims. What is the expertise of a person making the claim? What might they gain if the claim is valid? Does the claim seem justified given the evidence? What does the researcher think about the claim? Advertising campaigns often claim to be based on scientific evidence, when in reality it's based off of belief. So this is a system we use to assess if something is a belief, or if something is objectively true, or if it's subjectively true to one person. Obviously, through sensations and perceptions, we're going to learn that a sensation and perception can actually, it can give you some erroneous judgment, some pure incorrect judgment based on what you encountered throughout your daily life. So, yeah, actually, it's crazy that perception can actually shape how you think and believe, as stated in past chapters. So deductive reasoning, which is results that are predicting based on general premise. All living things require energy to survive. Premise: ducks are living things, therefore ducks require energy to survive. Conclusion. Oh yeah, so deductive reasoning and inductive reasoning, you're going to see these in philosophy. If you ever take philosophy, inductive reasoning is going to be pretty much inference, being able to infer that something is this based off observations and being able to connect the dots. And deductive reasoning is premises that are pretty much coherent, premises that connect to each other, and premises that make logical sense. So hypotheses are then tested through empirical observations and scientific forms. and scientists form conclusions throughout inductive reasoning. These conclusions lead to new theories and hypothesis, or a more broad generalization. So, by the way, theories and hypothesis are different. Theories are thorough theories. Theories are more thorough than a hypothesis. Theories have been tested steadily, while hypothesis can be more like a conjecture. But I don't know, conjecture and hypothesis are still not the same thing. But a conjecture, but it's like mainly just trying to connect the dots and mainly assuming based off a lot of logical principles. And some hypotheses are actually studied, but theories are usually generally more thorough cited and they have more objective statistical sightings to prove that they're theoretical, or to deepen or depthful, or make the theory more depthful. So psychological research relies on both inductive and deductive reasoning. So we're even using scientific methods in philosophy. Isn't that crazy? Scientists use inductive reasoning to form theories, which then generate a hypothesis. So a theory is a well-developed set of ideas that propose an explanation for an observed phenomenon. Hypothesis is a tentative and a testable statement prediction about a relationship between two variables. It predicts how the world will behave if the theory is correct, usually, and if then statement it's falsifiable, which is the capacity of being shown incorrect. And we actually do want a hypothesis to be falsifiable, so we know that we can make something incorrect. We know there's a dependency principle when we're looking at scientific methods. So the figure is the id ego, the superego, and the normal ego, which we're going to cover more in later chapters. Many specifics of Freud's theories, such as the divisions of the minds into the id, ego, superego, have fallen into favor in recent decades because they're not possible in broader strokes. His views set a stage for much psychological thinking today, such as the unconscious nature of the majority in psychological processes. So, and we also thought like a lot of the previously, like I said in the last chapter, some people thought you can observe the mind. Like behaviorists thought that you can strictly observe the mind and see what causes people to think in certain ways. But now we know that's not true. So clinical or case studies, naturalistic observations, surveys, and archival research, longitudinal and cross-sectional studies. What are these? So a clinical or case study focuses on one individual. The studied individual is typically in an extreme or unique or psychological circumstance that differentiates from the general public. This allows a lot of insight into the case of difficulty in results for the population. For example, Jeannie was studied by psychologists after she was found at the age of 13 having suffered severe abuse and psychological isolation. Psychologists were interested in the effect of social isolation that had, the effects that psychological isolation had on her development. So we're also going to look in a chapter called language. We're going to look at a language chapter, which is going to also bring up Jeannie again, about how we learn language at a critical period. But figure 2.7, observations and is in a natural setting. So you see that clinical or case studies are performed more with individuals. You see naturalistic case studies, like we're going to describe, are more in the natural environment. So we're just observing things that naturally happen. Maybe we'd observe a kangaroo in its natural environment. That's an example of a naturalistic study. So naturalistic behavior is generally hidden under security or observations. Seeing a police car behind you would probably affect your driving behavior. The study that is most accurate in genuine behaviors and naturalistic observation has proven most effective. So through naturalistic observations, any feeling of performance or anxiety of studied individuals is eliminated. Observer bias, when observations may be skewed to align with the observer's expectations. So it establishes a clear criteria to observe that should help eliminate observer bias. So bring them out to eliminate observer bias. Next, we have figure A and B. Jane Goodall made a career of conducting naturalistic observations of chimpanzees. So right here, this is obviously an example of naturalistic behaviors. You're going to see a lot of naturalistic studies in mostly studies for animals and things like that. So surveys is just a list of questions that can be delivered in many ways: paper, pencil, electrical, verbally. Surveys can be used to gather large amounts of data from a sample subset of individuals from a large population. Surveys can be administered in a number of ways, including electronically administered research, like the survey shown here. Dear visitor, your opinion is important. We would like to invite you to participate in a survey to gather your opinions on feedback and consumption habits. So, pretty much the survey is just a lot of people know what a survey is. You just take a question, and it's mainly to accumulate results and graph these accumulated results to see a lot of people's opinions on a lot of factors that goes on in the economy. Maybe who you think will win, maybe who you're gonna vote for. I mean, I don't think there's surveys like that. I don't know if there is. Probably, I'd assume. Just general questions for the public to help get the public's opinion on something. So archival research, which is using past records or data sets to answer various research questions or to search interesting patterns of a relationship. So archival research, the second I think of archival research, I think of history. So archival research, we're going to use past records and past patterns, or we're going to use something like, hey, maybe we're going to use past records like the Constitution to implement the Constitution in a judicial branch in our government system. Something like that is how I would look at archival research. So next is a longitudinal and cross-section study. A cross-sectional research compares multiple segments of a population in a single time, such as different age groups and different ethnicities. It could be different religious beliefs, people like that. A lot of people who are completely differentiated from each other, most likely, is what you're going to observe in cross-sectional research studies. So longitudinal studies, in which the same group of individuals are surveyed or measured repeatedly over an extended time period. Researchers often expect some participants to drop out, particularly in this type of study, and therefore often initially recruit a lot of participants. Attrition, reduction in number of research participants as some drop out of the study over time. So attrition, I think of attrition as in a history manner. You ever seen the word of attrition? Soldiers die, soldiers quit. You know, it's a war of attrition. We're just fighting until one person quits while all soldiers are falling and dying, blah, blah, blah. Something like that. Everything's subsiding in some insidious time. But longitudinal studies can be things like maybe studying habits with a person connected to a substance in an environment, maybe the likeliness of somebody or the likeliness of this person or multiple people, because a lot of people, like it said, can lead to longitudinal attrition. So we'll gather a lot of people in this study and we'll look over the years and see how many people were enticed and if they were likely to do some sort of substances within their environment. This is what longitudinal studies can help us with. So correlational research is a relationship between two or more variables. When two variables are correlated, one variable changes as the other does. Correlation coefficient, the number from -1 to +1, indicates the strength and the direction and the relationship between variables. So a positive correlation is going to be two variables change in the same direction but becoming larger or smaller. Negative correlation is two variables change in different directions, with one becoming larger as the other becomes smaller. So in these scatter plots, positive as, so like if we were to like how this says height and weight, what I saw a lot was maybe the weight of somebody and longevity. Maybe people who tend to weigh higher could have less longevity, and that could have positive correlation. And maybe negative correlation, people who are skinnier or people who are more fit, more of the average body type, tend to have negative correlation. They're gonna have longer lifespans with less weight. So one as the weight decreases, the longevity is going to increase. That could be an example of negative. Okay. So negative correlation, two variable. Oh wait, no, I'm reading the same thing. My bad. So anyways, correlation does not indicate causation. So cause and effect relationship, changes in one variable causes changes in the other variable. This can be determined only through an experiment or research design. Confounding variable, which is an unanticipated outside factor that affects both variables of interest, often giving false impressions that the change in one variable causes the other variable. So the confounding variable can create this sense of cause and effect relationships. So if there's a cause and effect relationship, we're going to think that there's one factor contributing to this other factor. So a confounding variable, like I said, a confounding variable is just that variable that can make you think that there's a cause and effect relationship, but there's actually some outside external variable that we need to look over. And cause and effect relationship, we can only say that these are actually, we can consolidate and solidify this. We can only say this is truth if there's heavy research on it to prove that there's a cause and effect relationship and there's no confounding variable. So correlation does not indicate causation. If someone eats cereal, people who eat cereal are generally lower weight, and that's just because people who eat cereal are children. So as well as mistaking correlation for causation, people can also make false correlations. An illusory correlation is seeing a relationship between two things when in reality, no such relationship exists. So we're going to see two things like maybe old people start, maybe these type of people eat ramen, when they're sad or something. Maybe there's some correlation between that. Maybe people throw mouses away because they're mad. Maybe you see someone get mad and then they throw a mouse like a couple of times, and you think there's some causation between that completely, when maybe it was a different fact. Maybe someone called them and they got mad and they were about to throw their mouse away, and you see some fictitious correlation between anger and mouse. Confirmation bias is a tendency to ignore evidence that disproves ideas or beliefs. So we're going to ignore things that impede or that break, pretty much, that destroy our argument or that destroy our belief, and we're going to accept things that aren't contrary to our beliefs. So things that are similar, things that are homogeneous to our beliefs. So many people have the belief that that full moon makes people behave oddly. Research demonstrates that the relationship does not exist. So that is an example of an illusory correlation. So designing an experimental group, the participants that experience and are manipulated variably, the group conducted is designed to answer research questions. Control group are the participants that do not experience a manipulated variable. They serve as a basis for comparison. And controls for chance factors that influence the results of the study. Experimental manipulation is one of the differences between experiments and control groups. So any differences between the two are due to experimental manipulation rather than chance. So defining variable and how they will be measured. Operational definition, the description of what actions and operations will be used to measure the dependent variable and manipulate the independent variables. So what this is saying is that experimental group is going to be the participants, and the control group are going to serve as a comparison between the experimental group. So next is designing an experiment, which we're gonna talk about later, or we're gonna talk about now on my turn later. So we have single blind experiments, single blind studies, and double blind studies, and then there's also a placebo effect that can cause someone to feel like something's happened. We've gone through this placebo effect before. So single blind study is an experiment in which researchers know which participants are experimenting in the group, and are in the control group, but the participants do not know. While double-blind study is pretty much an experiment where the participants don't know and the researcher does know to completely eliminate any sort of bias. So the placebo effect, which is when people expect or beliefs are influenced on or determined by their experiments in a given situation, when people are given the pill to improve their mood. So it's pretty much when someone informs you that something is going to happen and you think something's going to happen and you feel like it's happening. It doesn't exist. It's not even real. Your body's just making you feel that way. Providing control, placebo treatment protects against biases caused by expectancy. So variables, independent variable is a variable that is influenced and controlled by the experimental. Ideally, this should be the only important difference between the experiment. And the dependent variable should be focused on the independent variable, which is a variable that the researcher measures to see how it affects the independent variable, or how much effect the independent variable had. So, independent variable, type of television program viewed, dependent variable, violent behavior displayed. So, independent variable is going to be just this thing that we have, and the dependent variable is going to obviously depend and branch on from the independent variable. Like this discusses if you play some video game, which is going to be the influence, the independent variable, you're going to have the dependent variable is going to be seeing that you evoked or that you cultivated some sort of violent intent or violent ideology. Okay. So selecting participants, subjects of psychological research. The population of two sorts for a research evidence, so samples are used. Samples a subset of individuals selected from a large population. Populations are just overall groups of individuals that the researcher is interested in. So random sample is just a subset of a larger population, and every member of the population has an equal chance of being selected. This is a form of sampling, and it's preferred because it's more likely to be selected. Participants will be represented of large population. I can't say this because I'm on Roblox right now. Ethnicity, socioeconomic status, and etc. So researchers may work with a large population or be a sample group that is a subset of a larger population. So, okay, random sample pretty much just sounds like it. So, like a population, if you need an example, a population can be just college students. A population can be an ethnic group, and maybe a subset of that can be just a few individuals from that larger population. So grabbing those individuals from the ethnic group or grabbing some of the college students. So random assignment is the method of experimental group assignments in which all participants have an equal chance of being assigned to either group. It can be achieved using statistical software. Simply flipping a coin prevents systematic differences in a group such as gender or age. Without random assignment, an experiment cannot find a true cause and effect relationship. Any relationship can be due to pre-existing differences between groups. Random assignments help to avoid pre-existing systematic differences, so that significant differences between groups can be can be said to be the result of manipulation. So obviously in a lot of studies we're going to be targeting for a lot of random a lot more random activity within a lot of the studies, so we can get the most authentic statistics and the most authentic information and manipulation, and so we can see those independent variables raw. So issues to consider: manipulation variable, as stated, random assignment is required to state the causation. Ooh, bless me. Each group is then manipulated in some way. However, some experiments or designs are more complicated. Ooh. Examples that affect of male or female of the spatial memory. Independent variables cannot be manipulated. Males or females cannot be randomly assigned. The kind of experiment is therefore called a quasi-experiment. The cause and effect relationship cannot be determined from this experiment. Ethics, some question, cannot be answered using an experimental design because it would be unethical. Example, the effect of experiencing abuse of a child of levels of self-esteem. You cannot randomly assign partners to receive abuse. So pretty much manipulating variables. This is obviously not a random assignment. This is pretty much stating that there's a lot of ethics involved in this, and there's also some sort of manipulation on the experiment. And obviously, if you manipulate experiment, it's not raw, it's not ethical. If there's not any blindfolds or if there's not any random access, it can be called a quasi experiment because it's not real. It's a fake experiment. And you can't receive a cause and effect relationship from the experiment if it's not manipulated well and if it's false. Interpreting experiment's findings. Once data has been collected, a statistical analysis is conducted. Statistical analysis determines how the differences between the experimental group is due to changes. Psychologists usually discuss results as significant or non-significant if the odds that the differences occurred by chance are 5% or less. The results are significant. Then the results are, true experiment, including random assignment, manipulation of the independent variable, and control of the extraneous variables, reduce the odds of results occurring by chance. So like I said earlier, if we have a quasi-experiment, it's obviously not going to be truthful, and it's most likely not going to be authentic, and it's going to reduce the statistics on it. So, and there's also insignificance and significance, which we should be getting more into in later sections. So research is usually reported in scientific journals, usually aimed at an audience and at professional scholars. Articles published are peer-reviewed, and journal articles, peer-reviewed journal articles, are read by several other scientists, usually anonymously, with expertise in the subject on the matter, who provide feedback regarding the quality of the manuscript before it's accepted for publication. It helps to weed out the poorly conceived or executed studies, improves articles that suggest revisions, determines whether the research is described clearly enough to be replicated by other researchers, and replicants determine the reliability of the original research design can include an additional measure that expands on the original findings and providing more evidence to support the original findings or cast doubts. Reporting the findings obviously is going to tell us that if we're going to be reporting the findings, it's going to tell us that if we're reporting the findings, it's going to tell us that it's actually backed up. It has enough research. If we're getting a lot of people who are expertise in the field to check, obviously, and peer review a lot of the studies that are being published, then it should have formidable backup in a way, strong enough backup to be published and to be statistically right, and no chances, more authenticity in a way. So bad science and retraction, the vaccination autism mythic. So many peer-reviewed publications publish research making claims that the routine for childhood vaccines can cause a child to develop autism. Since these reports are on large-scale, research is carried out suggesting that the vaccinations are not responsible for causing autism. Many of the original studies have since been retracted. It was found that leading the research in the original studies had a financial interest to establish a link between childhood vaccines and autism. Fortunately, the initial claims were publicized, and many people still think the vaccinations cause autism. So reliability, the consistency and reproducibility of a given result. So reliability obviously is going to be something that we're going to rely on, and dependent and independent studies are going to be one of the easy causations to obviously root out the confounding variables and make sure those confounding variables are gone. So we're going to have a cause and effect, and if it can be reproduced, then it's going to be more reliable. So do instrument tools to collect data on reproduction when studying involve observation by multiple people? So and a reliability, my bad. It measures the agreement among observers on how to record and classify particular events. A reliable, consistent measure does not always mean that it is measuring something correctly. So validity, occurrence of a given result and measuring what it's designed to measure. Does a test measure what it's meant to measure? And a valid measure is always reliable, but reliable measure is not always valid. So can't always depend on a reliable measure. We always don't know if we have, or we can't always depend on reliability, and it has to be valid, obviously. And valid measures can be reliable. So, that's pretty much it. So we'll move on to ethics. So research involving human participation, institutional review board, committee, and administrative scientists, community members that review proposals for research involving human participants exists at any research institution that receives federal support for research involving human participants. Generally, IRB approves of research proposals before it can proceed. So we have some ethics involved when we're going to do an experiment. Informed consent, the process of informing a search participant about what's expected during an experiment, and then obtaining the person's consent to participate includes potential risk, implications of the research, notifications, and participation is involuntary. Notification of any data will be kept confidential, things of the sort. Deception, which is sometimes deception is necessary to prevent participants' knowledge of research, questioning, affecting results, and is considered harmful as long as it can have, oh my God, as long as it's not considered harmful. So deception, purposely misleading the experiment's participation in order to maintain integrity of the experiment. Debriefing, when an experiment involves deception, participants are told to complete the truthful information about an experiment after its conclusion. So ethical guidelines have not always existed. In 1932, participants were recruited in an experiment studying syphilis in black men. Participants that studied positive were not informed that they had the disease, although there's no cure existing at the beginning of the study. Cure was found in 1947, penicillin, but it was not administered to participants. Many participants unknowingly spread the disease and many died. So ethics and research involving animal studies. 90% of psychologists research involving animal subjects and use rodents and birds. Animals make substitutes because many of their basic processes are sufficiently similar in those humans. Animals are used when research would be unethical in human participants. Researchers must still aim to minimize pain or distress. So there is, and this is called IAUC, Institutional Animal Care and Use Committee. So there's still ethical concerns for humans, and there's still ethical concerns for animals to minimize pain when we're looking at researches. And we see deception and debriefing. And we see there's a lot more involved to research, like reliability and validity, and we see there's just a lot more stuff that comes deeply in research. I actually didn't think a lot about what really goes into research, but you can see there's statistics, there can be deception, there can be validity, there can be random assignments, there can be variables to make sure an experiment's right, causations and effects, things like that, even placebo effects in these, and it really just, there's a lot of things that come into research, which is something I didn't know, which I'm happy I got to learn about it, because I didn't know anything about this, especially this one. But yeah, that's going to be it. I hope you guys enjoyed. Thank you very much for tuning in to Psychology Chapter 2.